Hello everyone. In the last lecture, we studied about tensor quantities and the difference between stresses and pressure. In this lecture, we are going to study about the force and its types because we have talked about it in the last lecture. We also have to develop stress and the resistance which is required due to some external forces. Hence, we need to study about the force and its types. Let's have a look at it. In this lecture, we will be studying the force and the types of forces, then what are body forces and what are surface forces. First things first, when we talk about force, we need to know the definition. And the force is an external agent in the form of a push or a pull force on an object or a couple or a moment to which a component subjected when it comes into service. We need to look into the types of forces. We know that there are two types of forces. Let's have a look at it. The first force is called as the body force. The body force is distributed over the entire volume of the body. Example, buoyancy force and weight of the body, or the centrifugal force. The surface force is nothing but the force which is distributed over the surface or the line or acts at a point which is called as a surface force. Example, pressure force, drag force, or surface tension. Now the question is, which type of force is load in the strength of the material? Because all types of forces are not considered as load in the strength of material. In strength of materials, surface force is considered as load. But why is surface force considered as load? Let's understand it from an example. Supposing you are designing a bench. Now, what is the weight of the bench? One thing which we can tell from the weight of the bench is that the load is distributed all over the entire volume. In strength of materials, the surface force is considered as a load. But why is surface force considered as a load? Let's understand it from an example. Supposing you are designing a bench. Now, what is the weight of the bench? One thing which we can tell is that the weight of the bench is the load which is distributed all over the entire volume. Now, you are sitting on a bench. You are applying the force over the surface of the bench. And for the design point of view, we never check the weight of the body, or we never assume that the material will fail due to its weight. Because the weight is the volume force, and the volume force or body force never considered as a load in the strength of material. For better learning, let's take one more example. In the diagram shown in the figure, a pulley is mounted on a shaft and the weight of the pulley is W. We must design a shaft, and when we never consider the weight of the shaft as a load, we must design a shaft, and we never consider the weight of the shaft is a load because it is a body force. We only consider the weight of the pulley or any other members mounted on the shaft because the pulley weight is distributed all over the surface of the shaft. Hence, it is the surface force, that's why it is considered as a load. Now, after shaft, we must design the pulley. Before further discussion over this topic, let me clear one thing, that the weight of the shaft is nothing but considered as a load for the design of pulley because the pulley is mounted on the shaft and the shaft is not mounted on the pulley. Then, what type of load is acting on the pulley? The resultant force acting on the belt or the rope is considered as a load. So, till now we discussed the type of forces and which type of forces is considered as a load. And now I hope you will understand it very well. Now, if the body force is not considered as a load, it may be a part of the reason for the failure of the body. First, let me make the concept clear that failure doesn't mean that only breaking of a part or the material in engineering failure. that is, the displacement of molecules from their position, and it is showing that the body is moving towards the permanent failure. Let's take an example of a rubber block and hang it with the ceiling. We see that there is a deformation in the rubber block. Although there is a very small deformation, there is a deformation due to self-weight. Similarly, in real life, to increase the height of the child, he is advised to hang him against the bar. The increase in the height is nothing but the displacement of some human body tissues. From the above example, we see that there is some amount of deformation due to self-weight. Then why is self-weight not considered as a load? We neglect it to make our analysis simple, because if we conclude it in our analysis, then the problem becomes more complex. Hence, it is better to neglect it from the analysis, and later it is introduced in the form of the factor of safety to correct the value. So in this lecture, we read about the forces and the types of forces. But which one is considered as a load? And I am very much sure that none of you are able to identify that which type of force is considered as load in the strength of materials. Now, before ending this session, let's have some MCQs. It states that a pulley is mounted on the shaft. We must design the shaft, then which one of the following is considered as the load for the shaft? There are 4 options. Option A is weight of the shaft. Option B is weight of the pulley. Option C is weight of both pulley and the shaft. And option D, none of the above. The answer is weight of the pulley, because it is distributed all over the surface of the shaft. Hence, the answer to this question is option B. Let's have a look at the second question. For the designing of the pulley mounted on a shaft, which one of the following is considered as the load of the pulley? We have been given 4 options. Option A, weight of the shaft. Option B, weight of the pulley. Option C, resultant tension force of belt. Or option D, none of the above. It is a clear case observation that the correct answer is option C, because the resultant tension is force of the belt. Thank you for watching this, students. Please subscribe with our channel Ekeeda.